look at in this unit is solving rational expressions. And I just want to kind of remind you guys of some possible ways that you may have solved problems in the past. So if I had a problem like this with a lot of fractions in it, I can either add, subtract, multiply, and divide fractions, or if you recall, sometimes what we would do is we would multiply the entire equation, both sides of it, by a number that we knew would cancel out the denominator of the fractions. The number we chose is the same number you would choose if you were trying to find a common denominator. So with 2, 5, and 3, the common denominator would be 30. And if we multiply both sides of the fraction, both sides of the equation, or each term in the equation by 30, so that means 30 times 1/2 plus 30 times x over 5, 30 times 2/3, then you'll see that we would get 15 in our first term, 6x in our second term, and 3 goes into 30 10 times, and 10 times 2 is 20 for our third term. Now notice, we still have an equation to solve, but that helps us in the fact that now we don't have to deal with adding, subtracting fractions. Okay? So this is one way we can approach solving rational equations. Now notice there's a column to check, and that's because there are some solutions that won't actually work. Think back to your graphing and the values that made a function undefined. If we look at this first function, and we look at the denominators that involve variables, there are certain values of y that in no way can be a solution to this equation, even if it looks the same on both sides. So notice I've factored this last denominator. And when I look, I see denominators of y plus 2, 15, and 3y plus 2. The y plus 2 part of the denominator is the part that is concerning as far as the values of y might be concerned. If I solve this problem and I happen to get a solution of y equals -2, I'm not saying that's going to happen, I'm just saying if it did happen, that solution would have to be regarded as extraneous, and we wouldn't actually include that in the solution. And the reason being is because the fact that it would create undefined values in your equation wherever you plugged the -2 and it made a denominator of 0. What we are going to do is, like we talked about before, we're going to try and kind of get rid of the fractions by multiplying by a quantity that we would choose as the least common denominator here. The least common denominator is going to have a factor of y plus 2 because of these values here. And then numerically, we have a 3, and we also have a 15. 15 is 5 times 3, so it also has the factor of 3 already in it. So we can just use 15 in that case. Now remember, this would be our common denominator, or this is the value we would like to distribute to every term in this equation on both sides. So we're going to take each term and multiply it by what would have been the common denominator. And our ultimate goal is to not have any denominators left, to hopefully end up with an equation we can solve without having to use any fractions. So let's look at what happens at each of these terms as we multiply by the 15y plus 2. So in the first term, the y plus 2's will cancel, leaving us with 15 times 3, which is 45. In the second term, the 15's will cancel, leaving us with 7 times y plus 2. And on the other side of the equation, the y plus 2's will cancel. 3 will go into 15 5 times, leaving us with 5 times 23, which is 115. Now we can finish solving this equation by distributing the 7. And then solving like we normally would. I'm going to combine the 45 plus the 14, giving me 59. Then I'm going to subtract 59 from both sides of the equation, giving me 56. And I'm going to divide both sides by 7, giving me that y is equal to 8. Okay. Before I declare that my solution, I want to check. Again, the checking is mainly revolving around these extraneous solutions. So I'm pretty sure if I did all my algebra write that 8 is going to work because it's not negative 2, and negative 2 would be the only really big problem. So I'm just going to plug 8 back in to check. So this gives me 3 over 10 plus 7 over 15 equals 23 over 30. 30 would be a common denominator for these two fractions here. So if this becomes a 30, this would have to be 9. And if this becomes a 30, this would have to be 14, which adds to 23 over 30, which work out to be equal, which means my solution is y equals 8. In the next problem, so something similar. So think about what we're going to want to multiply this equation by. X minus 2. When we're looking at the denominators as we're writing this equation, notice that we see a factor of x minus 2. So that must be included in what would be the denominator. And then we have 6 and 3, but 6 includes a factor of 3, so we can just do 6 times x minus 2. Now remember, we're not going to make a common denominator. We're going to use this amount to multiply to each term, hoping to kind of get rid of or cancel the fractions so we can solve a simpler equation. So I'm going to multiply by 6 times x minus 2 in each term. Now, as I look at this, okay, in the first term here on the left side of the equation, I'm going to see that the x minus 2's cancel and that 3 goes into 6 2 times. That 2 needs to multiply the x plus 1, and that does involve distributing the quantity. Okay? So that's going to be 2x plus 2. Here, the 6 will cancel. The 5x needs to multiply the x minus 2, and again, that does involve distribution. So we have 5x squared minus 10x. In the third term, when the x minus 2 cancels, we're just left with 1 times 6, which gives us 6. So I'm going to note here that I notice it's a quadratic because of the squared value, and so I'm going to use some of my quadratic methods to solve. Remember that my options are things like factoring, quadratic formula, or completing the square. To decide what the best option is, for me at this case, I'm just going to wait first till I get everything on one side and then kind of explore what that might be. So the first thing I'm going to do is I'm going to check if it's factorable. If you have a different preference, then you have a different preference. And that is fine. But I think, let's see. There we go. So it factors as 5x minus 2 times x minus 2. And I would get my solutions by setting each of those factors equal to 0. So 5x minus 2 set equal to 0, and x minus 2 set equal to 0, giving me that x is equal to 2/5, or x is equal to 2. Now, looking back at the equation right away, remember, I don't want anything undefined. So notice that having x minus 2 in the denominator, if I try to plug this 2 back into the equation, I'm going to have undefined values. That's not okay. So right away, I'm going to eliminate the x equals 2 solution. Okay? And then I'm going to go ahead and check the 2/5 solution. Might take a little bit of work. So we'll see how this works out. Okay, so 2/5 plus 1 is going to be 7/5. 2/5 minus 2 is like 2/5 minus 10/5 is going to be negative 8/5 right here, essentially, times 3. So it's going to be like negative 24/5. And then here we're going to have 2 over 6. And then over here, 2/5 minus 10/5 again is going to be, this is going to be negative 8/5. So kind of the reciprocal of that, so it's going to be negative 5/8. So let's see if we can work this all out. Right here, 7/5 times the reciprocal of negative 24/5 is going to give us negative 7/24. Okay. Here, to make a common denominator, we can use 24 as our common denominator. And again, you're going to see you're going to get negative 7/24. Those things are equal to each other, so that solution checks out. The x equals 2 is extraneous, so we won't include it. Okay? All right, the last solving equation that we are going to look at. So I'm going to go ahead and first factor any denominators that aren't factored. Notice that 2r plus 1 factor shows up everywhere, but we have to account for a factor of 3 as well as a factor of 2. So I'm going to choose a 6 times 2r plus 1. Now again, the 6 was chosen to account for the factor of 2 as well as 3. I'm going to distribute that to each term and then see where that leaves me once I multiply each term by 6 times 2r plus 1. Okay, so now I'm going to go through again, cancel what I see can be canceled, and then try to work from there. So here I'm left with 6 times r plus 2, which is 6r plus 12. Here I'm going to be left with 2r times 2r plus 1, which is going to be 4r squared plus 2r. So it again looks like I might have a quadratic here. 2r plus 1 cancels, 2 goes into 6 3 times, and I'm left with 3 times 3. Which is 9. And again, I'm going to work on using my quadratic techniques, so I'm going to try and get everything on one side of the equation in order to solve it. So 4r squared minus 4r minus 3. So I'm going to see if I can go ahead and factor this. Let's see, 6 and 2. Okay, so let's see if this works. I'd get my 4r squared at the beginning and negative 3 at the end. Okay, so that works. So setting each of those equal to 0 to get my solution, 2r plus 1 set equal to 0 is going to give me r equals negative 1/2. And 2r minus 3 set equal to 0 is going to give me r equals 3/2. All right, so I have those solutions. Any ones I'm going to be weary of right away? When I look back, I can see the denominator of 2r plus 1. So if r was negative 1/2, that would make that equal to 0. So I'm going to eliminate that solution and know that just 3/2 is the solution. Now, just because we saw two problems where they came up with two solutions, and one was extraneous and one wasn't, that doesn't mean it's always going to happen that way. You might end up with 2. You might end up with none. You might end up with 1. Okay? So don't think there's some pattern there that's happening that just happened with our examples. But do check for those extraneous solutions that would make the denominators equal to 0.